SQ-Lite has been around for a long time by now, but was not as often used in iOS applications as it should be, for a number of reasons. It is an implementation dating back at 2001, and in 20 years a lot of things have changed. The data in the documentation eventually does not reflect the true date of the code, but some bugs, already present in XCode 6, were never repaired. So, here we go, with the definite bug fix everybody needs when storing a lot of data on a mobile device. First, we create a new single-view application. Then, we set the lowest target device version. We rename the main controller and clean up the code. We create a new Swift file for the SQLite database routines. We import the inbuilt SQ-Lite3 library. We create the SQ-Lite wrapper class. It is a generic object. In this class, we need a constructor and a de-constructor. This variable contains the database name for this application. It can be any name we wish, since it is stored in the application's private data space. This variable enables the recreation of the database at each application start. It is useful to test the creation and upgrade process. This variable defines the current database version. If you increment this value, already installed applications upgrade their database in order to reflect this version. This variable enables verbose printing of information. It is useful to debug your queries and get the full path to the database. This variable represents the placeholder for question marks in your query. You may change its value to something different if the query creation fails. This variable contains the pointer to the database connection. Opaque pointers are C pointers. We add now the code to the constructor. The call to the superior level is required. If the database name does not contain a slash, we add the full path to the application's private document space. If this value is set, we attempt to delete the database. Then we call a function to open or create the database. In the de-constructor, we simply close the database connection if previously opened. With this function we retrieve the path to the application's private document space. This function implements all features to open or create a database. First, we attempt to open an existing database. Then, we attempt to create a database. When created, an external browser can't open the database for write access. This function checks if updates are needed. It attempts to read the current database version. Then it loops from the latest recorded version to the most recent. After upgrading, it stores the version. Doing so makes it unlikely to upgrade a database again, even after a fatal crash. This function creates a new database. This function runs all the queries in order to create and upgrade the database. Please test your upgrades carefully, since failures on doing so are reason for hard-to-find problems of all kind. This function replaces the question marks of your query with an otherwise improbable character sequence. If this string can be found in normal field contents, the placeholder function fails. If this seems to be a problem, you may also generate a random character sequence in the constructor. This function escapes a string and surrounds it with single quotes, ready to use for queries. This function replaces a placeholder with a parameter. This function replaces placeholders with a number of parameters. Contrary to the SQ-Lite implementation, it does not generate an error if the parameter count does not match the placeholder count. This function executes a query with or without parameters. We will see later how it works. This function retrieves an integer value from the settings table. This function stores an integer value into the settings table. The following functions provide additional functionality for a practical example. You normally would use the basic database class and extend it as needed for each application. For the example, we will add an RSS parser. I will explain its details in another video. A typical RSS file looks like this. The RSS parser implements also a regular XML parser. During the parsing process, we also add some extra data and make date and time human readable. At this point, we attempt to compile, and then we check the code again. In the main controller, we add a couple of variables. The lazy statement indicates to initialize the class only when actually used. This portion of code downloads the RSS file and attempts to store its parsed data. Let's set a few breakpoints. The first attempt to run fails because the class name is wrong. Now we see how everything works. Since we need more information, let's switch debugging on. Before inserting the articles, let's check the database. We select the database name and drag it on the database browser application icon. Now we single step through all procedures in order to see how our implementation works. If we would change the GUID, the missing articles would be inserted again. That's all for today. If you have questions, please leave them in the comments. I'll be right back for you.